Lesson 6. Heat and temperature. Topics covered in the chapter. Temperature. Heat, form of energy. Measurement of temperature. Transfer of heat. Convection. The transfer of heat in liquid and gases. Radiation. Transfer of heat without a medium. It is a common experience that when two objects, one warmer and the other cooler, are placed in contact, the warmer object cools down and the cooler one becomes little less cooler. After some time, both the objects appear equally warm or cool. When such a process occurs, we generally say that heat is transferred from the warmer object to the cooler object. Now, the question is, what is this heat? What is the measure of hotness and coldness? How does it get transferred? In this chapter, you will learn something about heat, its effects, modes of transfer of heat, and applications. Temperature. We usually get an idea of coldness and hotness of an object by touching it. But hot and cold are relative terms. The sense of touch is not very accurate method to compare hotness or coldness of an object. A touch method cannot be used for comparing hot and cold bodies. The quantity by which we compare hotness or coldness of bodies is called temperature. Temperature indicates the degree of hotness or coldness of a body. Heat, a form of energy. When there is a difference in temperature between two bodies, a certain type of energy flows between them. This energy is called heat energy. You have already learned a bit about heat in class 5. If heat flows out of the body, it cools the body, while if it flows in a body, it warms the body. The point to note is that, left to itself, heat flows from a region of higher temperature to a region of lower temperature and never the other way around. Also, if you bring a hot body in contact with a cold one, heat flows from the hot body into the cold one till both reach the same temperature, whose value will be somewhere in between the temperature of the hot body and the cold body. In other words, the hot body loses heat while the cold body gains heat. Do you know it is possible to force heat energy to flow from a cold region to a hot region? To do this, we need to supply energy to the system. This is the concept used in air conditioners and refrigerators. The outside source of energy is electrical energy, unit of heat. Just as we measure length in centimeters and meters, heat energy, and any form of energy for that matter, is measured in calories or joules. In the SI system, which as you know is the International Standard System of Unit, heat energy is measured in joules. The symbol used to represent joules is J. Measurement of temperature. Temperature is measured by using a thermometer. Thermometers use some properties of a substance which varies with temperature. Mercury is used in the most commonly used thermometers. Before inventions of thermometers, a device called thermoscope was used to measure temperature. Earlier, alcohol was used in thermometers, but later, DG Fahrenheit used mercury in place of alcohol. Mercury thermometer. It is shiny and silvery white, so it can be seen easily from outside the glass. It does not stick to the glass. Mercury has a wide range of temperature with its freezing point 39 degrees Celsius and boiling point 357 degrees Celsius. Its expansion is fairly uniform over a wide range of temperature. It can be easily obtained in pure form. A mercury thermometer is used in tropical and temperate climate where alcohol thermometer is suitable in extremely cold climate because alcohol freezes at 117 degrees Celsius. The scale of temperature. A thermometer has graduations, markings, or a scale made on the basis of two standard temperature agreed upon universally. These are called the lower and upper fixed points. Usually, the lower fixed point is taken as the temperature at which ice melts, while the upper fixed point is taken as the temperature at which water boils. You know already that solid melts at particular temperature called their melting points, and liquids boil at a particular temperature called their boiling points. Thus, ice always melts at the same temperature and water always boils at the same temperature. The two commonly used scales for measuring temperature are the Celsius scale and the Fahrenheit scale. On the Celsius scale, the melting point of ice is taken as 0 degrees and the boiling point of water is taken as 100 degrees. After these 2 points are marked on a Celsius thermometer, the distance between them is divided into 100 equal divisions. Thus, equal divisions on the Celsius scale measure a temperature difference of 1 degree Celsius. This is the scale used in laboratory thermometers. Clinical doctor thermometers use the Fahrenheit scale on which ice melts at 32 degrees Celsius and water boils at 212 degrees. The differences between the 2 points is divided into 180 equal divisions. In other words, each division measures a temperature difference of 1 degree Fahrenheit. Do you know the normal body temperature is 37 degrees Celsius or 98.6 degrees Fahrenheit? Clinical thermometer. The thermometer used to measure our body temperature is called clinical thermometer. You must have seen it at your home when someone has fever. It is generally a mercury thermometer. It has fine thread of mercury running in the middle. It is seen when it shines. Use of clinical thermometer. Using a thermometer has a bulb filled with mercury and a glass stem with a thin, hollow tube running within it. The tube ends in the bulb at one end and is sealed at the other end. When the bulb is in contact with a hot object, the mercury gets heated and rises in the thin tube called a capillary tube. The marking up to which the mercury rises tells you the temperature of the object. Clinical thermometers have a kink in the capillary tube. The kink bend does not allow the mercury to fall as soon as the thermometer is taken out of the mouth. After you have checked the reading, you should give the thermometer a couple of sharp jerks to bring down the mercury column. Do you know, nowadays digital thermometers are used. They give the exact temperature of the body and mercury is not used in laboratory thermometer. To measure the temperature of other objects, we use different thermometers. One commonly used thermometer is laboratory thermometer. The temperature of it ranges from minus 10 degrees Celsius to 110 degrees Celsius. Laboratory thermometer also consists of a long, narrow, uniform glass tube having bulb at one end filled with mercury. It does not have a king. Use of laboratory thermometer. While reading temperature of a hot or cold body, it should be kept upright. The bulb should be dipped properly in the body while reading the temperature. You must record the temperature immediately because as soon as the thermometer is pulled out of the mercury, level starts falling. Maximum minimum thermometer. Another type of thermometer used to record the atmospheric temperature is called maximum minimum thermometer. It gives the maximum and minimum temperature recorded of various cities in the weather reports. Transfer of heat. When two bodies are brought into contact, heat flows from body at higher temperature to other body at lower temperature. Such a transfer of heat energy continues to take place till both attain same temperature. It takes place through conduction, conversion and radiation. First, conduction, transfer of heat in solid. The process of transmission or transfer of heat energy in solid without actual movement of particle from the position is called conduction. If we heat one end of metal rod by keeping it over a gas burner, we find that it is the other end also becomes hot after some. In this case, heat is transferred from the hot end of the rod to its cold end. Such a transfer of heat between two parts of the same rod is called conduction. To understand conduction occurs, we need to look into the composition of matter. You know Matter is made up of molecules. In solids, molecules are tightly packed. They are not free to move, but they can vibrate about their fixed positions. Conduction involves transfer of heat energy between adjacent molecules in a solid. Heat increases the vibration of molecules which collides with their slowly moving neighbors and make them vibrate fast. They, in turn, pass the vibration on to their neighbors and so on. Thus, heat energy is passed from one molecule to the next, although each individual molecule remains in its original location. Conduction is usually a slow process and can either occur within a body or between two bodies when they are in contact with each other. For example, cooking is mainly done by the process of conduction. It should be kept in mind that the conduction of heat stops when the two objects in contact or the other two parts of the same object have attained same temperature. This can be observed while measuring the temperature with the help of thermometer. When the bulb of laboratory thermometer is put in contact with a hot object, heat is transferred to mercury of the bulb and result in its level rise. Once the thermometer and object attain the same temperature, no more heat is transferred and level of mercury stop rising. Good and bad conductors of heat. Among solids, metals and their alloys are good conductors of heat, whereas non-metals are, in general, bad conductors or insulators of heat. Bad conductor means that heat does not travel through them. A metal spoon cannot be held for long when it is placed over a burner because it will conduct heat to our finger and our fingers will get burnt. But vessels with wooden handle can be held when they are placed over stove because wood does not conduct heat. We can also hold one end of sheet of paper in our hand even if the other end is burning. Similarly, we can hold a burning matchstick easily. Materials which allow heat to be conducted to them easily are called conductors or good conductors of heat. Materials which do not allow heat to be conducted through them easily are called insulators or bad conductors of heat. Liquid and gases in general are poor conductors of heat. Only mercury is an exception. Applications of conductors and insulators. Cooking utensils are made up of metals because we want heat to be transferred quickly, uniformly, and efficiently from the flame to the food. Some utensils even have copper base, as copper is better conductor than steel or aluminum. The handles of most utensils are made up of wood or plastic. Both wood and plastic are bad conductors of heat. Even when utensils are hot, we can hold the handle with bare hand and remove them from the flame. Cooling coils at the back of refrigerator are made up of copper so that they can readily conduct away heat. Walls and doors of refrigerator have two layers with insulating material in between them. This material prevents heat from the surrounding to enter the refrigerator. Roofs of shed and houses are made up of astaber sheets or clay tiles, as they are poor conductors of heat. If aluminium or iron sheets were used instead, they would conduct heat, so the shed or house would become unbearably hot in summers and very cold in winters. We wear woolen clothes in winters and feel warm because woolen fiber contains air trapped between them. Since air is a bad conductor of heat, so it does not allow the body heat to flow out. Or we can say that woolen cloths prevent the transfer of heat from our body to the surrounding. Second, convection. Transfer of heat in liquid and gases. In case of heat transfer by conduction, you observe that there were no actual movement of molecules. In case of convection, heat transfer takes place by actual movements of molecules from hot regions to cold regions. These mobile molecules carry heat energy with them. Heat transfer, in which heat is carried from the hotter part of the substance to its colder part by actual movement of hot particles, is called convection. Convection requires mobile molecule. It is not possible in solid because the molecule of solids are held strongly due to intermolar force. So it can take place only in liquid and gases and not in solid. Let us perform activities 2 and 3 to understand convection in liquids and gas. Uses of convection currents. Ventilators and exhaust fans are placed usually near the ceiling of room because the air we breathe out is warmer and lighter. So it goes through the ventilators. This causes a drop in the pressure in the room. Thus, more fresh air enters the room through windows and doors. Smoke and gas being hot rises and escape through chimney in industrial furnace. Heaters and blowers heat the room by setting up convection current. Firemen usually crawl while entering a building where fire has broken out because the hot air and smoke rise upwards. Sea breeze and land breeze. In coastal areas, the breeze generally blows from sea to the land during the day and is called sea breeze. At night, the breeze blows from land to the sea and is called land breeze. Sea breeze and land breeze are actually convection currents. As you're aware, water being a bad conductor takes long time to heat up than land and also takes longer to cool down. During the daytime, land gets heated up faster than water. The air above the lands gets heated and rises up. The cool air from the sea rushes to take its place. During the night, land loses its heat more rapidly than water. The air above water is warm and rises, and the cool air from land moves towards the sea to fill the space. The monsoon is also a convection current set up due to differences in temperature because the sea and the land level. Hot air in summer rises from the land and moisture containing cool air blows from the sea, thereby bringing rainfall on the land. Birds use convection currents of air to rise high and glide effortlessly without flapping their wings. Radiation, transfer of heat without a medium. For heat to flow by conduction or convection, matter must be present to carry the heat. When we stand in sunshine, we feel warm. Heat from the sun has reached us. Heat is transferred through another process called radiation. The heat energy which is transferred from a hot body to a cold body without needing any medium to travel and without being absorbed by space between the hot and cold bodies is called thermal radiation or radiant heat. The energy so radiated is called radiant energy. Radiation is a kind of electromagnetic energy similar to light energy. It travels with speed of light. When it is absorbed by some solid objects, the temperature of the solid objects. Radiation is the fast model of heat transfer from hot to cold body. Good heat radiators absorbers of radiant energy. Example, dark and blackened object. Poor heat radiators, absorbers of energy, radiant energy. Example, light colored, silvery and polished objects. Absorption of heat radiation by a body. The radiant heat of radiation can rise the temperature of a body when it gets absorbed by the body. When radiation falls on some solid surface, some parts of radiation can be absorbed, whereas rest part can be reflected. It is the part of radiation absorbed that raises the temperature of solid body. The amount of heat which an object can absorb radiation depends on the color of the object. The object having dark color absorb more heat than object having light color. Objects with black color are good absorbers of heat. Objects have shining white or silver color that are bad absorbers of heat. Applications of heat radiation. Radiation in cars and air conditions are painted black so as to have cooling effect by radiating most of heat. Room heaters reflect and thermostats have bright polished surface which acts as a good reflector of heat. Such surface absorb very little heat and reflect most of the heat radiation. solar cooker and water heater are painted black from inside. This is because black surface is good absorber of heat. Light colored buildings stay cooler in summer because they reflect most of the heat radiations from the sun. Coffee and tea stay hot longer in shining pot than in blackened one. Dark colored clothes are warmer in summer whereas white or light colored clothes are cooler. Keywords. Heat. Heat is a form of energy. Temperature. The degree of hotness or coldness of a body. Clinical thermometer. A thermometer used to measure the human body temperature. Laboratory thermometer. A thermometer used to measure the temperature of other objects. Insulators. Material which do not allow heat to be conducted through them easily. Conduction of heat. The transmission of heat to a substance from region of higher temperature to a region of lower temperature. Convection of heat. A process by which heat is transferred from one part of the fluid to another by movement of fluid itself. Land breeze which blow from the land towards sea at night time in coastal regions. Sea breeze which blows from sea towards land in daytime in coastal regions. Radiation, the mode of heat transfer that does not need a mean. Summary. Heat is transferred for a hot object to a cold object. Mercury has several characteristics, so it is used in making thermometers. Two commonly used scales to measure temperature are Celsius and Fahrenheit. The transmission of heat in solid takes place by process of conduction. In liquid and air, heat is transferred by the process of conduction. The heat from the sun reaches us by the process of radiation. Black-colored objects are better absorbers of heat. Shiny and white surfaces are better reflectors of heat. Take the correct answer.